National Electrical Code Section 400.8 prohibits the use of flexible cords above a suspended ceiling due to several safety concerns. Firstly, fire safety is a primary concern. A suspended ceiling acts as a fire barrier, designed to slow the spread of fire from one area to another. Introducing a flexible cord above the ceiling can compromise this fire barrier. The cord itself, or the device it powers, could potentially create a pathway for fire to spread more rapidly through the building. Secondly, electrical safety is paramount. A cord-connected device positioned above the suspended ceiling could come into contact with the ceiling grid, tiles, or other components. This contact could lead to electrical shock hazards if the insulation on the cord is damaged or if a fault occurs within the device. Furthermore, the device itself could overheat or malfunction, potentially causing a fire. Thirdly, maintenance is a significant consideration. Devices installed above suspended ceilings are inherently difficult to access for routine maintenance, inspections, or repairs. This lack of accessibility can lead to neglected maintenance, increasing the risk of equipment failure, electrical hazards, and fire. If a device fails or requires attention, removing ceiling tiles and working in the confined space above can be challenging and potentially dangerous. For these reasons, it is generally best practice to avoid installing cord-connected devices above suspended ceilings. The National Electrical Code reflects this concern through its restrictions on such installations. If there is a specific need to install a cord-connected device above a suspended ceiling, it is crucial to use a listed cord set that is specifically approved for the intended application. Such a cord set should be designed and rated to withstand the environmental conditions above the ceiling, including temperature fluctuations, dust, and potential physical damage. Additionally, the installation must adhere to all applicable electrical codes and standards, including proper support, strain relief, and protection against physical damage. Always consult with a qualified electrician or electrical inspector to ensure that any electrical installation is safe, compliant, and suitable for its intended purpose. Furthermore, alternative wiring methods, such as using conduit or cable, should be considered whenever possible to provide a more permanent and secure electrical connection. These methods offer better protection against physical damage and environmental factors, reducing the risk of electrical hazards and fire. When installing electrical equipment above suspended ceilings, ensure that the equipment is properly supported and secured to prevent it from falling and causing injury or damage. The supporting structure should be capable of withstanding the weight of the equipment and any additional loads that may be applied. Also, consider the ambient temperature above the suspended ceiling. Some electrical equipment may be sensitive to high temperatures, which can reduce its lifespan or cause it to malfunction. Choose equipment that is rated for the expected temperature range in the installation environment. Proper ventilation can also help to reduce the temperature and extend the lifespan of the equipment. Before working on any electrical system, always disconnect the power supply to the circuit being worked on. Use a qualified electrician to verify that the circuit is de-energized before beginning any work. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. When running electrical wiring above suspended ceilings, avoid creating sharp bends or kinks in the wiring. These bends can damage the insulation and create hotspots, increasing the risk of electrical fires. Use appropriate fittings and connectors to ensure that the wiring is properly terminated and protected. Also, be sure to label all electrical wiring and equipment clearly to facilitate future maintenance and troubleshooting. This labeling should include the circuit number, the voltage, and the function of the equipment. When selecting electrical equipment for installation above suspended ceilings, consider the energy efficiency of the equipment. Choose equipment that is energy efficient to reduce energy consumption and lower operating costs. This can also help to reduce the amount of heat generated by the equipment, which can improve its lifespan and reduce the risk of fire. If there is a need to run flexible cords above suspended ceilings for temporary purposes, ensure that the cords are properly supported and protected from physical damage. The cords should be rated for the intended use and should not be overloaded. Also, be sure to inspect the cords regularly for any signs of damage or wear. Never use damaged or worn cords. When installing electrical equipment above suspended ceilings, consider the accessibility of the equipment for future maintenance and repairs. Provide adequate access panels or openings to allow for easy access to the equipment. This will make it easier to perform routine maintenance, inspections, and repairs, and will help to ensure the safety and reliability of the electrical system. When working on electrical systems above suspended ceilings, be aware of the potential for asbestos exposure. Some older buildings may contain asbestos in the ceiling tiles or other building materials. If asbestos is present, take appropriate precautions to protect yourself from exposure. This may include wearing a respirator and following established asbestos abatement procedures. Finally, remember that electrical work can be dangerous. If not comfortable or qualified to perform electrical work, consult with a qualified electrician. A qualified electrician has the training, experience, and tools necessary to perform electrical work safely and correctly. By following these guidelines, electrical installations above suspended ceilings can be performed safely and in compliance with applicable codes and standards. This will help to ensure the safety of occupants and the reliability of the electrical system. Flexible cords should not be concealed behind building walls, floors, or ceilings. This is because concealed cords can overheat and cause a fire. Additionally, concealed cords are difficult to inspect and maintain, which can lead to neglected repairs and increased safety risks. Flexible cords should only be used for temporary wiring, such as connecting portable lamps or appliances. Permanent wiring should be installed using conduit or cable, which provides better protection against physical damage and environmental factors. Flexible cords should be protected from physical damage. This can be done by using cord protectors, cable ties, or other similar devices. Also, avoid running cords across doorways or walkways where they could be tripped over or damaged. Flexible cords should not be overloaded. Overloading a cord can cause it to overheat and create a fire hazard. Check the amperage rating of the cord and do not exceed it. Also, avoid plugging multiple appliances into a single cord using a multi-outlet adapter. Flexible cords should be inspected regularly for any signs of damage or wear. This includes checking the insulation for cracks or breaks, the plugs for loose connections, and the cord itself for any signs of fraying or kinking. Replace any damaged or worn cords immediately. Flexible cords should be properly supported and secured. This can be done by using cable ties, staples, or other similar devices. Avoid allowing cords to hang loosely or dangle from fixtures. Flexible cords should be kept away from heat sources. This includes radiators, heaters, and other appliances that generate heat. Heat can damage the insulation on the cord and create a fire hazard. Flexible cords should be kept away from water. Water can damage the insulation on the cord and create an electrical shock hazard. Avoid running cords through puddles of water or near sinks or other sources of moisture. Flexible cords should be used with the correct type of plug. The plug should be compatible with the outlet and should be properly grounded. Do not use adapters to plug a 3-prong plug into a 2-prong outlet. Flexible cords should be stored properly when not in use. This includes coiling the cord neatly and storing it in a dry, safe place. Avoid storing cords in direct sunlight or near heat sources. It is important to adhere to these guidelines to ensure the safe and proper use of flexible cords. Failure to do so can result in electrical shock, fire, and other serious hazards. Always consult with a qualified electrician if there are any questions or concerns about the use of flexible cords. Remember that electrical work can be dangerous and should only be performed by qualified individuals. Flexible cords are typically constructed of stranded copper conductors, which provide flexibility and conductivity. The conductors are insulated with a flexible material, such as rubber or plastic. The cord is then covered with an outer jacket which provides protection against abrasion, moisture, and other environmental factors. The National Electrical Code specifies the types of flexible cords that are permitted for various applications. The code also specifies the ampacity of each type of cord, which is the maximum amount of current that the cord can safely carry. It is important to select the correct type and size of flexible cord for the intended application to ensure safety and compliance with the electrical code. There are several different types of flexible cords available, each with its own unique characteristics and applications. Some common types of flexible cords include Type S, Type SO, Type SD, Type SJ, Type SJO, and Type SJT. Type S cords are general-purpose cords that are suitable for use in dry locations. Type SO cords are oil-resistant cords that are suitable for use in areas where they may come into contact with oil or grease. Type SD cords are hard service cords that are suitable for use in heavy-duty applications. Type SJ cords are junior hard service cords that are suitable for use in light-duty applications. Type SJO cords are oil-resistant junior hard service cords that are suitable for use in areas where they may come into contact with oil or grease. Type SJT cords are thermoplastic junior hard service cords that are suitable for use in light-duty applications. In addition to the type of cord, it is also important to consider the size of the cord. The size of the cord is determined by the number and size of the conductors. The larger the conductors, the more current the cord can safely carry. The National Electrical Code specifies the minimum size of flexible cords that are permitted for various applications. It is important to select a cord size that is large enough to handle the expected current load. It is also important to consider the length of the cord. The longer the cord, the more voltage drop there will be. Voltage drop is the reduction in voltage that occurs as electricity travels through a wire. Excessive voltage drop can cause equipment to malfunction or overheat. To minimize voltage drop, it is important to use a cord that is short enough for the application. When installing flexible cords, it is important to follow all applicable electrical codes and standards. This includes ensuring that the cords are properly supported, protected from physical damage, and not overloaded. It is also important to inspect the cords regularly for any signs of damage or wear. By following these guidelines, you can ensure that flexible cords are used safely and effectively.